right, so we are starting word problems today. So we're going to take everything that we've learned and we're going to apply it to some kind of context. So let's look at the do now. We're going to be dealing with discounts. So if Cameron pays a $15 fee to join a book club, he gets 10% off of the price of each book. So let's say that he wants to spend $70 on books. Okay, so if he gets 10% off of that, that means that he's going to only have to pay 90% of the original price. So 90%, I know as a decimal is 0.90 of means times the $70. So that means how much does he pay for the discount? What's the discounted price? So 90% of 70 is $63, okay? But remember that he had to pay the $15 originally. So the question is he getting a deal? So if you add these two together, you get $78, right? So he has two options. Join the club for $15, pay $78, or not join the club and pay $70. So will he save money joining the club? No, because $78 is greater than what he would have originally spent of $70. Okay, so no, it does not help us at all. All right, so can you figure this out? If he spends $250, will he save money? So you guys try and figure that out. You're doing part B on your own. Okay, so 90% of the 70, or no, this time he's paying $250, right? All right, of the $250, and then remember he's got this $15 fee. The question is this going to be less than the original amount, which is $250? That's the big question mark. So let's figure it out. So 0.90 times $250 is $225. So $225. So yes, $225 is less than $250. So he does get a deal here. All right, what about $100? Does 100? Oh, I forgot to add the $15 here, didn't I? So this is $225. Oops. So this is $225 plus the 15. $225, $235, $240. So $240 is still less than $250. So it works. So that works. $250 makes sense. I forgot to add the 15. All right, what about $100? Does $100 work? So the question is, if they pay the discount, that'd be $90 plus the $15 original joining fee. Is that going to be less than $100? What they would have spent without joining the club. So 90 plus 15 is $105. So no, $105 is greater than the original if you don't join the fee. So it wouldn't make sense to figure this out. So the question is, how much money does Cameron need to spend so that the cost of his books is the same whether he joins the club or not? Okay. So can you figure this out for me? You're going to do part D. Okay, so let's figure this out. So what I do when I teach writing equations is I say, do the math. Let's make some guesses, right? Do the math. What keeps on changing in the equation? So this kept on changing. And what keeps on changing, staying the same? So what kept staying the same was this 0.90, and the 15 also stayed the same. Okay, and then you can write an equation based on what stays the same and what keeps on changing. So I know the 0.90 stayed the same, and I know that the amount that he would have spent changes. So what changes becomes your variable. I know the fee to join the club always stayed the same, And I know that how much he would have originally spent stayed the same. So that we wanted to figure out at what point will the amount that they pay joining the book club be the same as the amount they pay if they don't join the book club. So that's why I chose to make the equal sign here. Okay. And then you just go ahead and solve. So minus 0.90 minus 0.90. Remember this, there's an imaginary 1 here. So 1 minus 0.90x is 0.1x. And then you divide by 0.1, divide by 0.1, and I believe this is $150. So if you got $150, you are correct. Doesn't matter which company you go with, or which option you go with, joining the book club or not joining the book club. If you spend $150, you'll pay the same amount. Okay? All right, so here, let's do this again. Vanessa is working 32 hours per week at her job. Her boss offers her a full-time position, 40 hours per week, and a $2 per hour raise. She says, that is great. Now I'll make 200 more per week. What is Vanessa's hourly wage before the raise? Okay, so we've got a before the raise option, and we have after the raise option. Okay, so before the raise, let's make a guess. Let's make some guesses. Let's say that she's making $10 an hour. What was she making before the raise? And what was she making after the raise? And the question is she making 200 more per week? So can you please try that real quick? Oops. All right, so before, after. So if she's making $10 a week, or $10 an hour, before the raise, she was working 32 hours at $10 an hour. So she was making $320. Now she gets a $2 per hour raise. So she was making 10. Now she's going to make 12. And she's also going to be working 40 hours a week. All right. So 40 times 12 is $480. So now the question is 480 minus 320 $200? So 480 minus 320, no, it's $160. So she is not making 200 more over here than over here. So let's come up with another guess. What do you think? $15 an hour? Okay, so if she's working 32 hours at $15 an hour, how much does she make? All right, now she gets a $2 raise. Now she's making $17 an hour. Okay, so 32 times 15 is 480. And then 40 times 17 is 680. Well, the question is 680 200 more than 480? Well, yes, it is. So we just guessed correctly. Okay. So they want us to solve this equation. All right. So 32W plus 200 equals 40W plus 2. Can you please solve this equation for me? All right, so minus 200. Oh, we got to distribute here. Oh, so let me start with that. I'm going to start over. Always distribute first. Okay. So 40W plus 80 equals 32W plus 200. All right, so now I'm going to subtract 32W. So I get 8W plus 80 equals 200. I'm going to subtract 80. So I get 120 is equal to 8W. Now I'm going to divide by 8. And 120 divided by 8 is the 15. So W equals 15. So the question is, how is this, what we did over here, similar to the equation that was given to us right here? So notice what stayed the same here was the 40 always stayed the same. Well, that's part of the equation here. The 2 always stayed the same. Well, that's part of the equation here. The 32 always stayed the same. Well, that's part of the equation here. And then we were always trying to see, was there a $200 difference? Was there a $200 difference? Well, that's where this came from, okay? What changed, okay? Well, the $10 changed the wage. The $15 changed. And over here as well. So that is where the variable came from over here. So I'm going to teach you this method called guess, check, generalize. And that's how we're going to solve word problems or come up with equations for word problems. Okay. So now the question is, what was Vanessa's wage before her raise? And what was her wage after her raise? All right. So before her raise, it was $15. Because that is what it had us solve. What was Vanessa's hourly wage before her raise? It was $15. That was at 32 hours a week. What was her wage after her raise? It was $17 because that's how much it increased by $2. Okay. All right, so what I would like for you guys to do is try number 4. An ancient Egyptian mathematician uses a concept of false position to solve equations. You guess a convenient number and then adjust it to find the correct answer. Here's an example. A number plus 1/4 of a number equals 210. What is the number? So a convenient guess is 4. Why is it a convenient guess? Why is 4 a convenient guess? Try it. Just put whatever, and I will read through it and see how close you get. So 4 is a convenient guess because 1/4 of 4 is 1. So when this number right here is a multiple of 4, like 1/4, oops. So 1/4, my 1/4 of 8 is a convenient guess because 8 is a multiple of 4. 1/4 of 12 is a convenient guess because 12 is a multiple of 4. That's why. So 4 is a multiple of 4, so that works. Okay, so what is 1/4 of 4? So 1/4 of 4 is 1. Okay, does 1 equal 210? No. So we need to go much bigger. Okay, so suppose that your guess is 12. What do you get? So 1/4 of 12 is 3. And 3 is not equal to 210. Okay, so 12 is way too small. Can you see if you can figure this out now? We have to go way bigger. All right, let's say 1/4 of 400. Well, that would be 100, which is not equal to 210. So we're still way too small. So let's try 1/4 of 800. Well, that would be 200. So we're getting closer, but it's not equal to 210. So at this point, we can take our guesses and put in a variable. And I know of means multiply. Okay, so right now, 1/4 x is equal to 210, because that's what I'm trying to get is 210. So now let's undo this by multiplying by the reciprocal. So x is equal to 210 times 4. So we get 840. So that is our answer. Hopefully you got something close. So this is a getting started with word problems. These problems are really hard in this lesson. So I saved a bunch of them for us to do tomorrow during our independent work because I know you're going to have a bunch of questions. But this is just to get you guys started thinking about this stuff.